In this video, we're going to discuss trigonometry. So we've been dealing with right triangles for a few chapters now. One of the first things we saw is that all three angles added up to 180 degrees. So if you knew you had a right triangle, then you knew this angle was 90. And that must mean the other two angles add up to 90. Because 90 plus 90 is 180. So if you knew this was 90 and you knew this was, say, 75, well, this angle must be 90 minus 75, or 15 degrees. So we learned how angles relate to one another. Then next, we learned how sides relate to one another through the Pythagorean theorem. The Pythagorean theorem was a squared plus b squared equals c squared. So if you knew two of the sides, you could get the third side. What we're going to do now is see how sides and angles relate to one another. So the way that sides and angles relate to one another is through a ratio. What you need to do is take a ratio of two sides. So a ratio is just like a fraction. You're going to have one side divided by another side. And there are several different ways we could do this. We could divide, let's say, side A divided by side C. So these two sides. Another way we could set up a ratio is we could divide this side, side B, by side C. And then a third way, we could divide side A by side B. So you'll see with these three examples, we've divided side A by C, side A by B. So we've divided side A by all the things it could be divided by. But side C, we haven't actually divided that by anything. So let's do that next. We could do side C divided by side A. Or we could do side C divided by side B. And then finally, we've only divided B by one of the other two sides, C. We could have divided B, whoops, let me go back. We could have divided B by side A. So there's 6 different ways to make a ratio with these 3 different sides. And you'll see each ratio only involves 2 of the 3 sides. And the cool thing is, these relate to the angles. So this ratio right here, A over C, we call that the sine. And specifically, right now I'm talking about this angle right here. So the sine of angle A is equal to A over C. And we abbreviate sine S-I-N, but sine spelt out is S-I-N-E. And then this ratio here, we call that the cosine. We abbreviate that C-O-S, but it's cosine, C-O-S-I-N-E. The ratio of A over B, we call that tangent. We abbreviate it tan, but it's tangent. C over A, we call that the cosecant. Of angle A. And then the next one, C over B, we call that the secant of angle A. That's S-E-C-A-N-T. And then finally, B over A, we call that the cotangent of angle A. And you'll notice all of the abbreviations are simply the first 3 letters of the word, except for this one. Because if you use the first 3 letters of cosecant, it's the same abbreviation as cosine. And this is much more common, so it gets to use the C-O-S, and this one is the C-S-C. Another thing is, you'll notice I've sort of paired them up. These two are related to one another. See how the fraction is just flipped? This is A over C, this is C over A. These two are related to one another. This is B over C. This is C over B. And then these two are related to one another. This is A over B, and this is B over A. So their ratios are simply reciprocals of one another. And as a result, yes, there's these 6 trigonometric functions, but we really don't need to concern ourselves with these over here. So yes, they're important, and they are used, but if you can do sine, cosine, and tangent, you can easily figure out cosecant, secant, and cotangent. So let's take a look at this a little bit more. There's another way to sort of label this rather than A's, B's, and C's, and I think it makes it a little bit easier. So we're just going to focus on sine, cosine, and tangent. You'll see I have it written twice because over here in this column we're going to be focusing on angle A. So angle A is right here. And then over in this column, we'll do that next and we'll focus in on angle B. So you may remember that the sine of A, we said that was A over C. And we said A was right here and C was right here. But we should write this more generally. So if you look at this angle, this is the angle we're interested in, the opposite side is over here. Let's label that with an O. And then this side right here is right next to angle A. So let's label that with an A for adjacent. And then this side is special. It's opposite the right angle, so this is the hypotenuse. So rather than using A's, B's, and C's, because those letters could change depending on how your angles are marked, let's think about the opposite side of the angle, the side right next to the angle, and then the hypotenuse. Now I know the hypotenuse is right next to the angle as well, but we don't call it adjacent because it itself is special in the fact that it's the hypotenuse. So the sine of the angle, you might remember from the previous slide, was B over C, but another way to think of it is opposite over hypotenuse. And then whatever those letters happen to be for those sides, you can substitute them in there. Cosine of this angle is adjacent over hypotenuse. And then the tangent of the angle is opposite over adjacent. So this is all for angle A. Now let's take a look at angle B, and I'll switch colors. So let's do angle B in blue. Angle B is over here. So if we were to follow along with what we did over here for sine of A, we did opposite over hypotenuse. But now for angle B, the opposite side is over here. So the adjacent side for angle A is the opposite side for angle B. And then same thing over here. This was the opposite side for angle A, but it's the adjacent side for angle B. And then this is still the hypotenuse. So the sine of B is opposite over hypotenuse. The formula looks the same, but when you see how it's labeled, opposite for angle A is here, and opposite side for angle B is here. For cosine, it's adjacent over hypotenuse, and then tangent is opposite side over adjacent side. And a simple way that you can remember this is by remembering SOHCAHTOA. And what this stands for is the sine. So our first set is opposite over hypotenuse. Ka stands for cosine, is adjacent over hypotenuse. And then TOA stands for tangent, is opposite over adjacent. So whenever you're working trigonometry problems, I would encourage you to write that at the top of your paper just to use as a reference. Okay, let's take a look at an example. So what we're asked to do here is to fill in our fraction, because the sine, cosine, or tangent of an angle, it's simply a ratio of two of the three sides. Let's remind ourselves. So, ka, toa. All right, let's work with angle A first. If we are taking the sine of an angle, sine is opposite over hypotenuse. But we want to fill this in with actual numbers. So here's angle A. Opposite is 5.5. Hypotenuse, oh, we're not given that, but we know two of the three sides. So we can use the Pythagorean theorem. 10 squared plus 5.5 squared equals x squared. And when you solve that out, you end up with x equals 11.41. So our hypotenuse is 11.41, that goes right here. And then we can simplify that into a decimal number, and that is 0.482. So this is the ratio of this side to this side. And you could think about that as a percentage if you move the decimal place over. And what it's saying is this side is 48% the length of this side. All right, let's look at cosine. We're still working with angle A. Cosine is ka from so katoa. So cosine is adjacent over hypotenuse. The adjacent side to angle A is 10, and the hypotenuse is still 11.41. And when you calculate that out, you end up with 0.876. Finally, tangent. That relates to toa in SOHCAHTOA. So tangent is opposite over adjacent. The opposite side to angle A is 5.5. The adjacent side is 10. So if we write that as a decimal instead of a fraction, it's 0.55. Okay, so that's great. We've figured out the ratios that relate to angle A. But what we're really interested in is what the actual angle is. So we want to be able to use these ratios in order to tell us, okay, is this angle 20 degrees or 30 degrees or 40 degrees? What is the angle? And the angle is A. So right now with sine of A, we have sine of A equals 0.482. And we are interested in getting this by itself. So the way you undo sine is you have to do the inverse. So rather than having this number by itself, we want A by itself. So we're going to flip-flop these two places. And when we do that, we change something about this. We write this symbol here. It looks like it's raised to the -1 power, but this is telling you to take the inverse sign. And there should be a button on your calculator for you to do this. If you're not sure how, let me know and I can help you out with that. And when you take the inverse sign, what you get for an answer is 28.8 degrees. So on this one we have cosine of A equals 0.876. So if we want A by itself, A is the inverse cosine of 0.876. And again, you'll find a button for that on your calculator, and when you do that, you end up with 28.8 degrees. And then tangent of A equals 0.55. If we want just A, we have to take the inverse tangent of 0.55. And when you do that, you get 28.8 degrees. And did you notice all three of our answers are the same? But they should be, because over here, all we're talking about is angle A. So every single calculation we're doing is for this angle. This is the same angle in all three of these problems. So we should end up with the same answer. So when you're actually trying to figure out what is the measure of angle A in an actual problem, you wouldn't go through and do sine and cosine and tangent. You would look at, well, what sides are available to me? In this case, we didn't have this side available to us originally. We had the opposite side and the adjacent side. So we could have just jumped right into doing the inverse tangent of 5.5 over 10, or 0.55, to get the angle of 28.8 degrees. So when you're working actual problems, you're not going to go through this long process that we're doing right now. I'm just showing you all the different ways that you can do it. Okay, so we know that this angle is 28.8 degrees. We know that this angle is 90. We know all three of these angles have to add up to 180. So that must mean that angle B, let me switch my color, it's got to be 61.2 degrees. But let's go through this process just to be sure. So sine is opposite over hypotenuse. The opposite side of angle B is 10. And then the hypotenuse is 11.41. If we want to figure out what B is, we need to take the inverse sine of that ratio. And in decimal form, that ratio is 0.876. And if you take the inverse sine of 0.876, we get 61.2 degrees. And I'm rounding a bit. It might come up like 61.18 or something like that. But we're rounding in all of these problems, so it's not going to be exactly on 61.2, just like I rounded to say that this angle here is 28.8. Okay, cosine of angle B. Cosine is adjacent over hypotenuse, so that would be 5.5 over 11.41. If we want to figure out what is angle B, we're going to take the inverse cosine of that ratio. That ratio in decimal form is 0.482. So the inverse cosine of 0.482 is 61.2 degrees. And again, we're talking about angle B both times, so it should work out that we get the same value for our answer. Finally, tangent. Tangent is opposite, so 10 over adjacent, 5.5. So the tangent of B is 10 over 5.5. If we want to figure out B, we need to take the inverse tangent of that ratio. That ratio in decimal form is 1.818. And no surprise, when you do that calculation, I'll write the number over here, you get 61.2 degrees. Okay, let's take a look at an example. We are told that angle A is 19 degrees. What are the lengths of the other two sides of the triangle? So we want to figure out, well, what is this? And what is this? And something that I didn't ask, but is often asked as well, is to complete the triangle. And what that means is a triangle has 3 sides and 3 angles. So it has 6 pieces of information. It has angle A, angle B, angle C, and then it has side, we'll say A, side B, actually I should have used a C here, and then side C. So this is side A because it's opposite angle A. This is side B, this is opposite angle B. This is side C because it's opposite angle C. So sometimes you'll be asked to complete the triangle, and that just means fill in these 6 pieces of information. Well, we're given angle A, 19 degrees. We are given side C of 10. We know angle C is the right angle, so that's 90. And we know all of these have to add up to 180, or these 2 angles, being the non-right angles, have to add up to 90. So this should be what? 71 degrees. So we need to figure out sides A and B. And there's different ways that you could approach this. So I am going to work on figuring out what is side A first. And I know side A is right here. It is opposite of angle A. And I'm given 10, which is adjacent. So we need to think about what ratio. So we have SO, CA, TOA. And the ratios are here, the O, the A, and the OA. What ratio is opposite and adjacent, or adjacent and opposite? And that would be tangent. So we're going to write out the tangent of A is opposite over adjacent. We know A is 19 degrees. The opposite side, that's what we're trying to figure out. So I'll just leave that as O. And then the adjacent side is 10. If we rearrange this, we get 10 times the tangent of 19 equals our opposite side. So you plug in tangent of 19 into your calculator and you get about 0.3443, and then multiply by 10, you end up with 3.443. So that is side A, 3.443. At this point, if you wanted to figure out side C, you could do the Pythagorean theorem. However, you weren't given this number, you calculated it, so it's always good to try to go back to your given information and figure out the answer. So we were given the fact that angle A is 19 degrees. We were given the adjacent side, and we want to know the hypotenuse. So think about what trigonometric function combines adjacent and hypotenuse. And that'd be cosine. So the cosine of 19 degrees is adjacent 10 over hypotenuse. That's what we're trying to solve for. We could rearrange this and say the hypotenuse C is 10 over the cosine of 19 degrees. The cosine of 19 degrees is about 0.9455. So 10 divided by 0.9455 gives us 10.58. So our third side is 10.58. And then you could confirm this with the Pythagorean theorem. 3.443 squared plus 10 squared, and then take the square root of that. You should get about 10.58. And I say about because we are rounding here, so you might be off in the hundredths or thousandths place.